Solving equations with radicals. Alright, so we know how to perform every operation on radicals, whether it's adding, subtracting, multiplying, dividing, and even rationalizing radicals. So now we're going to work on solving equations with radicals. So if we had something like x minus 4 equals 7, the point here is to get rid of the radical. The way you get rid of radicals is by squaring an entire side of an equal sign. So if I just square both sides here, radical x minus 4 times radical x minus 4 is x minus 4. And 7 squared is 49. Add 4 to both sides, x equals 54. So that's the basics of solving equations with radicals. But in this example we had the radical already isolated. So if we had something like 2x minus 1 plus 2x minus 1 is the radicand, equals 5. The radical's not isolated, so let's do that. Subtract 2 from both sides. You get radical 2x minus 1 equals 3. Now we can square both sides. Square that, square that. 2x minus 1 equals 9. And now this is easy to solve for x. Add 1 to both sides. 2x equals 10. And divide by 2. X equals 5. Both of these equations yielded a linear equation to be solved. That's not always the case. If we had something like radical 3x plus 16, part of radicand, minus x equals 2. Well, the radical's not isolated yet, so let's add x to both sides to get the radical alone on one side of the equal sign. We're going to add x to both sides, so positive x plus 2. Now when you're squaring the entire side of the equal sign. When we have a binomial over here, so when we square both sides, just remember you're not squaring terms individually, you're squaring an entire side of the equal sign, which means x plus 2 is appearing twice. So when we square the radical, it just gets rid of the radical sign. And in this case, I'm just going to write x plus 2 twice to remind myself to FOIL. Let's FOIL this side. X times x is x squared. X times 2 is 2x. 2 times x is another 2x. And 2 times 2 is 4. And we still had a 3x plus 16 there. So I filled this. Got all that. And now I have a second degree equation, which means I have to get this into standard form. So I'm going to combine like terms over here. So let's rewrite the 3x plus 16. 2x and 2x is 4x. And now we'll subtract 3x. And we'll subtract 16. To set it equal to 0. So now I have 0 equals x squared plus x minus 12. Now that it's in standard form, we can factor. X plus factors of 12, 4, and 3. So 4, negative 3 equals 0. Let's set each factor equal to 0 and solve separately. X plus 4 equals 0. X minus 3 equals 0, giving you x equals negative 4 and x equals 3. Now, just like the absolute value equations, if you have a variable on the outside of radicand, you have to plug it in and check. So let's plug in negative 4 to check. We're plugging it into the original equation here. So we had radical 3 times negative 4 plus 16 minus negative 4 equals 2. Negative 12 plus 16 is 4. Square root of 4 is 2. 2 minus negative 4 is 2 plus 4 equals 2. 6 equals 2. Reject. Let's now plug in 3. 3 times 3 plus 16 minus 3 equals 2. 3 times 3 is 9. 9 plus 16 is 25. The square root of 25 is 5. 5 minus 3 equals 2. Yes. So our only solution is x equals 3. Because when we plug in x equals negative 4, we get a false statement. So reject that solution.